Hello and welcome to this Codefresh live event, feature-rich pull requests. Josh Dolitsky is our speaker today. He has been a part of the Codefresh team in the past and remains the creator and primary maintainer of Chart Museum, an open source project supported by Codefresh. Josh, why don't you take us away?
Hi, so I'm Josh Dolitsky. I worked previously with Codefresh, so I'm happy to be back here doing this in partnership with them. I'm a software engineer with about 10 years experience building web apps, APIs, doing build automation, working with cloud providers such as AWS, Azure, Google Cloud. Write mostly Golang at this point, but have a lot of history with Python and JavaScript as well. I'm involved with the Helm project. So Chart Museum is a project I created almost 2 years ago, which sort of got me involved with the team that was building Helm. And now I am one of the org maintainers of Helm, which means that I'm sort of aiding in making sure that the project's going in a good direction. And recently been working on Helm 3, which is the newest version of Helm that is unreleased, and doing some interesting things there, such as making it, adding the ability to do Helm push, Helm pull, Helm login. So keep an eye out on Helm 3. But anyway, so Codefresh, this is, if you're unfamiliar with Codefresh, Codefresh is a fully featured CI solution. What's kind of unique about Codefresh is its native compatibility with Kubernetes. So it's really a great platform if you're just getting started on basically moving everything into containers and moving everything to Kubernetes. Codefresh has everything that you need to get there. So for example, there's a built-in Docker registry that you can use, and it has a built-in chart repository, multi-tenant chart repository that's built on top of Chart Museum in the background. And it also has dashboards which I'll show you in a bit, but it has dashboards for seeing all the different services in your cluster, all the different Helm releases that have been installed, as well as the ability to set up different automation pipelines for projects across different repositories and on different triggers. For example, when a change merges versus when a pull request comes in. And the pull request piece of things is actually what we're going to focus on. So, so I talked a little bit about Chart Museum. When a pull request comes into an open source project, a lot of times you'll notice, if you've ever submitted a change to an open source project, or this also happens with internal private code as well, but there will be some automation that sort of picks up upon check-in. So basically giving the change submitter basically feedback, like very quick feedback. So if I'm making a change to a big project and those maintainers are busy with their day job, or they're on a vacation, or they just have too many other PRs that are on their plate that they can't get to it, with this automation, usually it will give you, a red X or a green check. Hey, this this change looks good. And so that by the time the maintainer comes in, they can basically see that the test pass and merge the change. One of the things that's I think often overlooked is that depending on your test, depending on what that automation does, that basically the pull request can be used as a sort of kind of an attack vector. Basically, you don't know if the change coming in is going to, for example, launch some containers on your infrastructure and mine Bitcoins or harvest credentials, sort of doomsday scenarios. But you basically get the picture that the environment that's running your tests may have access to certain credentials for AWS or some cloud provider, or access to secrets that should remain on the CI system, or it's launching. It's basically running a dynamic environment of their code, and the code itself might be doing bad things. So basically, we're going to look at the different tools that Codefresh offers you to basically combat this system or combat that type of issue. But beyond that, like I was saying before, is when people are submitting a PR change, they want that feedback. So one of the interesting things we can do is, and this obviously depends on the source code or the application, but if we have a process in place for continuous deployment, we can actually, per pull request, launch an on-demand environment. And then when that pull request is closed, automatically tear it down so that we're not wasting resources. Wasting resources on our infrastructure. And also, there may be multiple stages of this. You may want to launch a test environment, and then after the fact, run Selenium tests or any other type of verification tests on that deployment to basically, make sure that the change is doing what it's supposed to be doing. So we're going to do a bit of heavy demoing here, but here's the basic agenda of where we're going to go, starting with basic pull request actions. So if you come to your Codefresh dashboard. By the way, I did not mention, but the source code for this is available at CF demo account or CF demo ACC/super app. So if, I'm going to be walking through all sorts of files in this repository. So if it's helpful, you may want to pull up this this URL, and let me actually throw it into the chat just to make it even easier here. Oh, it looks like Taryn already did it. Well, thanks, Taryn. So yeah, so here's, for those of you who aren't familiar with the Codefresh UI, here is basically the landing page. So you set up you can set up multiple repositories on GitHub. So here's the kind of the management API or the management UI for this repository. And just to really quick walk through the sample application. We have two directories here. Let me zoom this a little bit. So we have two directories, app and deploy. So pretty important to separate the deployment, the code that's used for deployment. In this case, we're going to use a Helm chart to deploy the app, and then also the source for the app separately. So in this case, it's in one repository. I typically, depending on the size of the code base, like to split these into two different repos. But for our cases, we will just treat them as one. The application is a simple Lua-based web server. So the reason I chose Lua, Helm 3 is going to ship with basically a built-in Lua engine, so you can start writing charts with Lua script. So kind of to prepare for the incoming the influx of Lua and to understand the language, I started playing around with Lua. So I found a framework called Lapis, and I would probably, I don't know, kind of compare it to a Ruby on Rails for Lua. And you can actually even write the code with this language called MoonScript. I didn't want to dive into MoonScript today, maybe next time, but focusing on Lua for now. But basically, very simply, it allows us to basically put routes and return some stuff. It also does database and modeling. I cannot get into that today, but certainly going to play with that later. But here's a really basic URL definition. You know, you pass in the name and it says welcome to the profile of your name. So we're going to play around with a little bit with that in a few minutes. But this is the app, and then in the deployment folder, we have a Helm chart called Super App. We're going to use Helm file to deploy this. Helm file is a really interesting project. It allows you to basically put an array of all of your different releases that you want in the environment. And it also has support for environment variables. So we can actually use this one Helm file to deploy an environment based on that namespace variable. And it also has defaults and stuff. So if I'm running this locally, for example, which I'll show you here, running Helm file apply, looks like I already have. Yeah, I already have this deployed, super app -local. But anyway, this is just going to be the mechanism that this is kind of a wrapper around Helm. And here's our chart. Our only variables here are, and the important one for us is the image tag. We're basically going to use the image tag as a way to set up, push artifacts that are specific to, or push images that are specific to a pull request coming in. And basically, when we deploy the Helm chart to create a dynamic environment, we're going to modify. We're going to give it its own namespace in Kubernetes. We're going to name everything with that namespace, so it comes up as a separate Helm release. And then we're going to modify this image tag, which is actually the Lua code that is running the web server. And we just have two resources here: a deployment, which runs our pods, and and then our service, which routes stuff to the pods. But back to Codefresh. So that's the demo application that we'll make some modifications to. Yeah, so in Codefresh you can actually add multiple pipelines for each repository. So you're not limited to, say, run one type of automation. Like typically you see, I check into master, run this build. That's that's the baseline example that Codefresh gives you. However, you can set up different things based on different actions. So to walk you through sort of some of the things that Codefresh allows you to do is you can trigger based on all of these different GitHub actions. So notice all the ones with pull requests on them. So we may want to run something. We may want to run a pull request the minute something opens. We may want to look at that username, the username of the person submitting the pull request, and maybe compare it to a whitelist of people who we trust. You can see this done in the Kubernetes project all over the place. They have owners files which list all of the contributors that are trusted to make changes, and then they'll run the automation automatically. What we're kind of going to focus on, so obviously all sorts of different things we can trigger on if someone's added a label, things like that. The one that's super interesting to me is this pull request common added. Pull request common added, and basically this is sort of getting into advanced pull request actions. Pull request common added, you can add a regular expression here that will basically, if an owner or an admin of the GitHub repo says a comment that matches a regular expression, it will launch the pipeline. So we have this set up, and this will kind of walk through how we're going to do dynamic pull request environments. So we have, the first one we have set up is dynamic env create, or dynamic environment create. So our rule set here is, you also have the option here to allow things from forks versus a branch. So which means, typically means more anonymous, less trusted sources. So if an owner of the repo, in this case, it's this little Gopher user that I've created, CF demo account, says /launch on a pull request, that's going to run this pipeline. And if we look at what the pipeline actually does, this is going back to GitHub. So for those of you who have this repo, if you have this repo pulled up, all of the different pipelines that we're looking at today are under this .codefresh. And that's sort of a pattern I've been following that helps keep all of these different pipelines organized. But you're also, welcome to put them at the top level or wherever. Anyway, back to the dynamic environment creation pipeline. In other examples I've shown where you're building the application kind of in one pipeline, pushing that artifact, and then in some other pipeline deploying that artifact. In this case, very simple. We're building Docker image that has our Lua web app, pushing it to Docker Hub, and we're going to tag it using the pull request number. So that basically, any environment that we spin up, or anytime we run this pipeline, it's being unique to that pull request number. So we're never getting multiple environments per a single pull request. There's at max 1 environment per pull request. So we're pushing the image with the custom pull request source code here. And then we're going to deploy the chart, and we're going to set that namespace variable. Remember that in our Helm file, this is being used to determine 3 different things. Our the name of our release. So when you do a Helm list, that's that name field. Namespace. This is the actual Kubernetes namespace. And Helm file is really nice. It will actually create that for you if it doesn't exist. So we don't need to like do kubectl create nspr123. And then also lastly, the tag for the image source from Docker Hub, which we've pushed right here. Helm file apply will compare the diff between your YAML file and your Helm list output, and install the things that aren't there yet. So it's going to install this PR-123 release. This stage can mostly be ignored. We're using the load balancer service type. So this is basically waiting for an external IP to become available. So it's just looping. It's just on a while loop and checking using kubectl to see if that external IP exists. So this will kind of spin for a while. Once the endpoint is available, we're going to use this Cloud Posse GitHub commenter image, which is really nice. It basically takes a set of environment variables, and as long as you have a GitHub API token set up in the environment, which I can show you is right here, encrypted GitHub token. As long as that's there and you pass the PR number and some other required fields, it will, using a bot, in this case we don't have a bot, but using a bot will make the comment, hey, here's your endpoint, so the user who submitted the request can start looking at it and testing things out. So without going much further, let's put together a simple change. And if you hear silence, I am typing, my keyboard is very loud and mechanic. So here's our application. Let's do something very simple. So right now it says, if you go to let me see if this is actually, if we have a master version running yet, really quick. All right, looks like nothing's up. All right, well, here's one that I deployed locally. So this is what the app does. Try to get it so you can see both. When we come to the root address, it's basically saying welcome, and then go to this link, which is it's basically giving, I think it's /Josh URL, and then this is a handler for actually /Josh, which just says welcome to the profile of Josh, I think. So I think what we can do is maybe just add a picture here. Let's see. I'll use this image. Get rid of this stuff. So I'm just going to make a guess here of how to use this framework. It looks like I can just sort of I would assume I could do something like that. Maybe I can search the docs here a little bit. Okay. Well, that looks like to me what you would do there. So all right, so I've just pushed that to a new branch called image using my personal account. So now, I'm signed in as myself in this window. Now, if I come to pull requests and say new pull request, compare across forks, choose the new, you can see I have several test branches. Did I not commit? All right, so I basically pushed a branch even with master. So if I refresh this, okay. Now we have the image. Hopefully that's how you do that. So I'm going to create the pull request. So I open this pull request, and then you'll notice when we come back to Codefresh, basically nothing has, these were from before, nothing has launched here. And that is because of what we talked about with the comments, with the pull request comment trigger. And I'll just look at that one more time before we just dive in. This is what that looks like. You're setting up pull request comment added, forks allowed. So coming from my account versus the CF demo account. And then saying if an owner says /launch. So I'm now logged in as this person, and if I go to the pull request and I'm being basically making sure that there's no Bitcoin miners or credential harvesters in the source code, so I can let's imagine this is a much larger change with I don't know, like a bunch of different changes to business logic, but it looks safe. Okay, I'm now confident that this can go on for further verification. So what I'm going to do is type the as an owner of the repo, type that /launch command, and that should trigger a dynamic environment. So just after a few seconds, you can see Codefresh talking back to GitHub and saying, here's this here's this job that's running, and it's pending. Also, as an owner, this is a pretty interesting thing. As a repository admin, you can actually put protection rules on branches. So I can say, like, for example, I want to require dynamic env create on the master branch. So in order to get something into this, this needs to pass. So now if I come back here, it should have a big red. As an admin, you can still merge as pull requests. But you get the point that this needs to basically pass in a typical scenario for that to merge. So let's see. I'm going to open this in incognito window. And what you'll notice is that this is actually viewable without having a Codefresh account. And the reason that is another thing that's really useful to for the open source use case is this public build logs checkbox. So you need to be careful with this because this will expose your build output to the world. But as long as you're generally careful about exposing credentials, I know that there is also work being done at Codefresh to do more like being more aggressive about masking credentials as well. But basically, this is really nice because if I come back to my personal account, I'm not signed into Codefresh in this browser, yet I can check this out. So if something were to fail, it looks like it's, wow, it actually maybe did fail. Something's wrong with that. In any case, if something went wrong with this build, you could go to the individual step and maybe see, oh, I have a syntax error, I forgot a comma, XYZ. But it looks like everything went through. So we've built the Docker image, and we've pushed it with this PR-10. So if you look at the pull request coming in, it's number 10. This Codefresh basically provides a number of at runtime variables that you can use. So if a trigger or an event's coming in from a pull request, then we're basically given all of these CF underscore pull request mvars that we can do different things with. So that's how that's passed in there. And then once that image is pushed, we're going to deploy using Helm file. And this, I'll go back to my own account. Yeah, so we deployed with Helm file. It's seen that there was no super app PR10 release. And then went ahead and did the installation. We waited for the public IP to be ready. So you can see in this step, we're getting that IP address. And then finally, we're using this Cloud Posse image to publish a comment back to the GitHub pull request. So let's go back and see what that looks like. All right, so I've set this up with an API token for CF demo account. If I had more time, I would make a brand new GitHub account and put a robot face on it, but let's assume this is a robot. So this is great because now let's say I'm coming back. Oh, this is not even the right window. Hold on. Okay. So now I'm logged in as Josh, and all right, this build has passed, and this URL is here. Now I can click on it and check it out. All right, and now we have our fancy image. I'm glad that was the correct way to do that. So we're not limited to one of these pull request action verbs, right? So we can actually set up another pipeline that just runs verification tests on this. Where is it going with? Yeah, so this has been deployed to the testing environment. You may then, once it's up, want to, I'm just saying this again, run verification tests against it. What we can do is set up another trigger, which I'll do here. I think I was starting to do so earlier. All right, so I mean, this is, if we had more time, we would go into the amazing things you can do with Codefresh test reports. There's a great blog here by Kostas on the Codefresh blog that shows you how you can, if you put files in a certain location on the volume, they're automatically uploaded using a custom mechanism, and then you can actually see the results next to your builds with this view log. But anyway, for right now, we're not really going to run a test. We're just going to comment back to GitHub and say the tests are passing. But instead of the slash launch action, instead we're going to require the slash test action. So you may want to take different actions against a incoming pull request, depending on the different series of events or what the change is doing, things like that. So now me as the blue gopher, I've looked at this and it looks good to me. All right, I'm going to allow this to go through for testing. So I make this comment, and the expectation is that this starts at test PR. So really, probably the right branch protection we want is for the test PR versus dynamic mcreate. And let's see where that's at. So yeah, one of the things that we can improve on here, if we took this to the next step, there's a lot of inspiration from the types of things that go on with Kubernetes and the Helm charts PR systems. Like, for example, if I've run /test here, let's say the tests fail. All right, so our bot has said that the tests pass, yay, and that makes this green, so I can merge the pull request. But back to what I was saying a minute ago. Let's say the tests fail, and this was not the case, and this turned red. I may have, as the maintainer, have taken off for the day, or can't get back to it for another few days, whatever. If the user who's already, let's say, trusted at some point has basically comes in and submits a change that fixes, that adds the missing comma or whatever. Right now, as it stands with our setup, we're going to have to manually wait for a maintainer to come in and say /test again. And that kind of ruins the part of the purpose is to have that fast feedback loop. So we can do really interesting things here by basically, if we want to, we can basically make a trigger and put complete custom. If we just do any pull request event trigger, you can actually, I was talking about the Codefresh global environment variables, look at the pull request action, look at who did it, do a bunch of custom stuff. Who knows, you can even talk to a database that has a list of trusted PRs and trusted people. I wouldn't go that far, but the idea is to keep the interaction in GitHub so that the person's able to iterate on the change and get the feedback ASAP. So this is great. This all looks great. So I'm as a admin of this repo, I'm going to, let's say this looks good, and I'm going to merge it. Now, once this merges, you'll notice that well, it's going to launch two different pipelines here. So if Codefresh has these great UI panels for Kubernetes and Helm. So I can see this PR10 service that's running here, right? This is the one with our change. This was just for PR10, right? It's even linked into its own namespace. You can see it's running the PR10 image here. For a different view of this, you can come to this Helm releases section. You see you have the super app PR10 Helm release. Oh, well, that's because we're deleting it. So you can see this is gone now. What we've done here is, and just to tie everything back, I think we're a little bit past on the slide. So we went over launching the dynamic pull request environment. We went into broadcasting test results back to GitHub. So using GitHub API and bots to talk back to the PR. We can also, do interesting things like use a bot to add labels, things like that. Now what we're going to get into really quickly before we're done here is the automatic teardown of the environments. So you notice that pull request was closed. It was merged, right? It doesn't matter if it was merged, if it was denied, if the original submitter said, I don't really like this anymore, I'm going to cancel this. Basically, we're going to launch a pipeline that is solely responsible for cleaning up the environment that was previously created just for that change. And really all that this looks like is the inverse of the create pipeline. So we looked at dynamic env create earlier. Dynamic env delete. All that this is going to do is source that CF pull request number again to get the namespace variable, that Helm file. Well, we're not using Helm file for the delete process at this point. However, using that namespace to delete the correct thing. So all that this is doing is using Helm to list what are the releases in this namespace. So Helm file created the PR10 namespace, installed the PR10, installed the super app PR10 release into that namespace. And now that namespace is completely useless to us because the PR has been merged. This is in master now. It's in production. We don't care. So when the pull request is closed, we set this up. We set up this dynamic m delete, and you can see it's pointing to that dynamic m delete in the repo. And our action here is PR closed. So we're looping through this crazy one-liner is just looping through all of the Helm releases that are in that namespace, deleting them with a purge. And purge just means just completely destroy it, get rid of any, what's it called? PVCs, etc. And then we're going to use kubectl to actually just nuke the namespace. We don't need it at all. And that can be seen in, we didn't view it in real time, but this was the pipeline that was triggered from there. And you can see release super app PR10 deleted and namespace PR10 force deleted. Great. Lastly, we have our master pipeline. The master pipeline is essentially a clone of dynamic mcreate. We'll look at the file really quick. The only difference is that it doesn't have the extra steps that talk back to the PR and say, here's your URL. In this scenario, we may want to actually talk to our company Slack and say production, or let's not even say production, staging. Staging has been deployed at this URL. QA team, look at this and see if it looks good, things like that. But we're using the exact same mechanism of Helm file and just keying off of that namespace. So instead of PR-10, we're just using a namespace called branch name, or branch dash master in this case. So upon merge to master, that ran. And here's your output. Here's Helm files deployed, super app branch master. And now if we go to our Kubernetes dashboard, and this obviously, you can do this with kubectl as well. And here's your the IP of we'll call this our production instance. But Codefresh is nice. It pulls us all together across all namespaces, which is really nice. But here's kind of our production service, and now this beautiful image has made it into production, and now the company makes a lot of money. So that is pretty much all I have for the demo. So just to go over really quick what we did here, we set up general continuous integration, continuous delivery for a web app, in this case, one that was written in Lua using Lapis. We're now able to, as the maintainer of the project, and this also all applies for internal. It's not all just open source. All these types of things, although you may trust the incoming PRs more, the automation side of things is still very important. We're able to field PRs with confidence, so any incoming changes from coworkers or anonymous randoms, we're able to, using advanced mechanisms powered by Codefresh, we're able to say this change that's coming in is doing all the right things and passes our criteria. And in real life scenarios, I recommend everything from unit tests, acceptance tests, deployment verification tests, running things like Selenium, anything that you can to, obviously it's all specific to your application and your setting, but anything you can do to verify that changes aren't breaking things that are working for people. And then we've also shown how we can make use of Helm, and obviously other tools could work with this flow as well, since you're keying off of the pull request number. But using Helm in this scenario to deploy our application for the pull request as a one-off, and then automatically tearing that down when the environment's no longer needed or when the pull request closed. And again, we have this, all of the source code we went over is open source online. Sorry for the sort of confusing account name, but it's CF Demo ACC or CF Demo account / super app. And that's it for today.
Thank you so much, Josh. And I just want to remind everyone that you can try a free Codefresh account at codefresh.io. That's 120 builds a month. And also make sure and check out our upcoming events at codefresh.io/events. That includes all of our webinars. Thanks, and we'll see you next time.